Well, friends, today I am taking transportation problem, all aspects, all points regarding transportation problem. We know this is my given exercise, and this exercise is to solve transportation problem to maximize profit. We know that the transportation problem is for minimization, number one. The problem should be of minimization of cost, time or distance. But when the transportation problem is of maximization problem, then we have to convert the given transportation problem into minimization or converting the problem into opportunity cost. And the technique for that is subtracting all the elements of the given matrix from the highest element. Then we will get converted this transportation problem into minimization. Then we will proceed further. Second point is the transportation should be balanced one. Demand must be equal to supply. Here demand is less than supply. It means we have to create dummy demand of 50 units. So 2 points simultaneously. One is that you are to convert this problem. This is a given problem, original problem. You have to convert this by subtracting all the elements from the highest number, and highest number is 44. It will be converted as minimization problem. And secondly, it should be balanced one, so we have to add dummy 50 units dummy demand 50 units by adding dummy you can say column. Dummy demand is required, so we have to add dummy column. So this is the first point, that converting it into dummy and then making it a balanced one, we have to do it simultaneously. So let me make it these 2 points simultaneously. Here is A, B, C. This is factories, and these are the stores. 1, 2, 3, 4 stores are given. We have to create another dummy stores so that we can have dummy demand to make it 200. So these are the stores 1, 2, 3, 4 and dummy store with 0 cost. So first we will convert this problem by subtracting all the elements from the highest number 44. It is 4, 0. Let me draw first. And here we will have supply. Here it is demand. Now we are converting this problem into minimization. So it will be 6. Again 44 minus 25, 19. 9 and 6, again 22, 44 minus 22, 44 minus 13, 14 and 44 minus 28, 16. So 44 minus 33, 11 and 14 and again 14. Here in the dummy we have to add 0 cost. Now the demand is 40, 20, 60, 30 and we require 50 more units. So more 50 demand we have created, dummy demand, and supply is 100, 30, 70. So it makes 200. Now it is balanced problem as well as a minimization problem, and these are the no cost elements. These are the cost elements. Originally it was for the profit elements, but now we have converted into minimization problem. Now we will solve this problem by VAM. We know the northwest corner method is very simple, and that is never recommended to get the optimum solution. And again, least cost entry method is better than the northwest corner method, but again VAM is the best to reach near to the optimum solution. So for VAM, this is also called unit penalty method. So we are to calculate unit penalty, difference between minimum to the next number. If minimum, there are two minimum number, then the difference will be 0. So this is like difference between the minimum to the next minimum. Minimum to the next minimum. So these are just you can draw. We can proceed further. So these are the unit penalties. Unit penalties 1, again 1. So here these are unit penalties. For calculating unit penalties, we require minimum 2 rows, 2 columns. If there is 1 row or 1 column, then we cannot calculate unit penalty. So difference between minimum is 0 and maximum next minimum is 4. So unit penalty is 4. Minimum is 6, next is 9, unit penalty is 3. Minimum is 14, next is 16, 2. Minimum is 14, minimum is 11, next is 14, 3. It is 0. Now here, row wise, minimum is 0, maximum is 4, next is 4, minimum is 0, and it is again 0. Then minimum is 0, next is 6, so it is 6. After calculating unit penalty, we are to check the maximum penalty. We are to enter maximum penalty. If can be tie, then we will see from which maximum unit we are to enter. Now here is single maximum penalty is 6, so we will enter from this side. And we will allocate the units to the minimum cost. Allocate the units to the minimum cost, and minimum cost is 0, so we will allocate 50 over here. And by allocating 50 over here, this column is satisfied because we are to keep demand and supply intact. Now this is 50, it is over now. Okay. Now next difference, this column is not here. Then next is minimum is 4 to 11, 7. Second difference, second penalty, 4 to 11, 7. 0 to 9, 9. And then 6 to 6, 0. 6 to 6, 0. Because these two are minimum, so it is 0. Again here 0 to 4, 4, 6 to 9, 3, and 14 to 16, 2, and here 11 to 14, 3. Again in the second unit penalties, second differences, maximum is 9, so we will enter from here. When we enter from here, then we are to find the minimum cost, and minimum cost is what? This 0 is the minimum cost. Here we can either 40 or 30. So keeping intact the demand and supply, we can allocate 30. Still this column is there, but this row has been satisfied. There is no row. No row has been satisfied because 30 units has been allocated. Now third time Now this is not there. This row is not there. We have to keep in mind that this row is not there. Then this row and this row difference is 2. This 19 and 6 difference is 13. Because this is not there. 19 and 6 difference is 13. 22 and 16 difference is 6. And this is 11 and 13, 3. Here difference is, no, this is not there. Now difference is minimum 4 to 11, 7. And here, this is not there. We can't calculate. The difference will be 0. So the maximum difference will be 13. Here it is 13. So we will enter from this side. And entering from this side, we can allocate maximum 20 units. Maximum 20 units, that too at the minimum cost in this column. Minimum cost in this column is 6. So 20 units are allocated. Now this unit demand has been satisfied. This 70 unit has been satisfied. Now B row and C row, second and third row has been satisfied. Their demand or supply has been satisfied. So only one single row is left. And here we have 1, 3rd and 4th column. But if there is a single row or single column left, you cannot calculate the differences. You cannot calculate the unit penalty. Then you have to make the adjustment. So here adjustment means, say starting from this is the 100 units. We are to supply, add this here 40 units are required, 30 units had already been allocated. So 10 units, only 10 units can be charged. 10 units, no 40 is there, it is okay. Now 100 units left. Here no unit can be allocated. Here 60 units can be allocated. 60. When you allocate 60, this is okay. 60. And here now 30 units are left. Here 30 units are to be allocated. And this is also allocated. Demand is okay. Now here 30 is okay. Here 70 is okay. Now 10 plus 30, 40. 20 is okay, 60 is okay, 30 is okay, 50 is okay. Means all the demand and supplies have been satisfied. So this is the VAM. You have applied VAM. Vogel approximation method is also known as unit penalty method. And this is the best method. So best method. Now we can calculate the total cost. Total cost is cost into units. Cost into units. Cost into, these are cost. Cost is in, these are squares. Cost 4 into 10 plus 22 into 60 plus 11 into 30 plus 0 into 30, there is no idea of writing down 0 into 30 is 0. So 6 into 20 plus 0 into 50, there is no idea of writing down 0 into 50. So this is further equal to 40 plus 1320 plus 330 plus 120. So the answer is, total cost is 0, 5, 7, 1, 6, 9, 1, 2, 5, 18 and 2. This is the total cost. This is the total cost. Now we are to see that this total cost is the optimum. There is no further chance of improvement. That is why here it is written apply test for optimality. Now today we will go for test of optimality. Test of optimality. There are two tests. There are two tests. Test of optimality. There are two tests. Number one is stepping stone. Stepping stone method. And number second is modified distribution method. Modified distribution method, generally it is known as Modi, modified distribution method. So these are the two methods, different techniques of calculating optimum answer, but the condition for the going for optimality is that these are the rim requirements. These are the allocations. Here, these are the allocations. These are the assignments, you can say, in circle. The number of assignments should be equal to m plus n minus 1, where m is the number of rows, n is the number of columns, and minus 1. So number of assignments should be equal to, this is the number of assignments. Number of assignments should be equal to m number of rows, there are 3 rows, n number of columns, there are 5 columns, minus 1, so 7. So number of assignments should be 7, but here the number of assignments are 1, 2, 3, 4, 5, 6. It means if the number of assignments are not equal to, the problem is non-degeneracy. Non-degeneracy, we have to make the assignments equal to the rim requirements. These are the rim requirements. So then we have to add dummy epsilon, you can say epsilon, symbol epsilon like this, at minimum cost and independent position. If your assignments are not equal to the requirements means number of assignments should be number of rows plus number of columns minus 1. So there should be 7, but now it is 6. You have to make it 7, then add epsilon is the symbol, mathematical symbol, at minimum cost and independent position. So minimum cost and independent position is, say this is the minimum cost here because we are to turn from the corners, so this is the epsilon. Now the assignments are, we have added one more assignments, so assignments are equal to 7. Now we have to apply these two methods. We have to understand these two methods simultaneously. What is the purpose of a test of optimality is that the squares where there is no assignment, whether that can be any assignment, we have to find the opportunity cost of the blank cells where assignment has not been made by any method, because generally we use RAM. So we have to check whether the blank cell there is any opportunity cost negative. It means then the most negative opportunity cost has to be assigned any number. So it's a very particular technique of reaching at the optimum solution. So stepping stone method says, according to this method, that these are your blank cells. These are your blank cells where no assignment has been made. These are your blank cells, and these are the occupied cells where assignment has been made. So according to stepping stone method, starting from the blank cell, please try to understand, starting from the blank cell, go in any direction, either this or this or this, but you are to turn at from the occupied cells. Occupied cells. You cannot move in the three directions simultaneously. You have to move from the blank cell to either to this direction or this direction or this direction. And again from the occupied cell you have to move like this. Like this. So I will let you know how to move. The ultimate purpose is to, in stepping stone method, you have to create a cell. You have to create a circuit. You can say circuit. You have to create a circuit, closed circuit. And circuit can be like this. For example, this is the blank cell. It can be like this. Exactly same. Or it can be like this. Or it can be like this. Or it can be like this. Point to be kept in mind is, starting from the blank cell, you are to move in the direction where there is a occupied cell. And again from the occupied cell, you have to move in the direction of another occupied cell, and ultimately you have to come back. You have to come back. If you start from here, then you are coming back to this. If you are starting from here, this turning point should be from occupied cell. Turning point should be from occupied cell. And your circuit, or you can say loop, can be square, rectangle, or whatever the shape it takes. There will be definitely a one closed circuit starting from the blank cell, movement to the occupied cell, and turning from that occupied cell to again to the occupied cell, and again turning, always turning at 90 degree. No in any other direction. Turning at 90 degree. So let me tell you, so this is the point to be kept in mind. Only then you can have this stepping stone method. So this is the blank cell. Say. Actually, this is the blank cell. Now you have to move either this or this or this or this. But you have to come back from the occupied cell. So it means if you go from this to this and this and this, then you will come over here. So blank cells, let me make it more clear, because the problem is to calculate the opportunity cost of the blank cells, whether there is a chances of allocation or not. So this is A2, first row, second column. This is A2. From A2 move to A dummy, or you can say this is fifth, A5. Then to C5, then to not C5, this is second, C second and again to A second. Try to understand from this. From here you can come like this, then go to this, then go to this, then come back. You are to move from the blank cell to the occupied cell and turn from there to the another occupied cell, again turn from there to the occupied cell and come back to that cell. This is what the stepping stone method is. So this is A second. From A second you are moving to A5, then you are coming to C5, then you are going to A second and again going from A second to this your A second. So this, from this to this and this, then you are going back. This is your C second to A second. So this is the technique. So here you have to start like this, plus, this is plus, minus, plus, minus. It's very simple to remember, plus, minus, plus, minus. So plus, minus, plus, minus, so 19 is the cost, it is plus, minus 0, plus 0, minus 6, so it is 13. 19 minus 0 plus 0 minus 6 is 13. So 13 is the opportunity cost of this blank cell. Now the next blank cell is this. Again we have to start from here in such a way that you are to come back to this point. So you cannot move in this direction, you have to go this way, then from this to this, then this to this, this to this, then here, then you will come. So from B second to B second to B first to A1, then to A5, then C5. It is a little bit lengthy. Then it is C second. Then you are coming to B second. From this to this, again from this to this, then from this to this, from here, here to here, here and here. So there are two ways. One is from here to here, this to this, this. You can identify the route. From 9 to 0, 4, then it is from 0, again 0, it is 6, then 9. So it is plus minus, plus minus, plus minus, plus minus like this, alternatively. So 9, you can come to like this, 9 minus 6, 3, plus 0, minus 0, plus 4, minus 0, it is 3 plus 4, 7. So opportunity cost is 7. Now this is the blank cell. Now you have to try and search out the circuit. That is the simple funda of drawing the circle is starting from the blank cell, go to the direction of occupied cell and take the turn from that occupied cell to another occupied cell, again take the turn and come back to the cell and calculate the opportunity cost by plus minus plus minus. So here it is very simple now, 14. From here go to this, this, this and again this. So 14 minus 22 minus 8 plus 4, so it is minus 4. Again 14, go to this, 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 this and this. This you have to find. From 14 to 11, occupied cell. Again come to 4, 10. Again 0, 30 and you will come back. So 14 minus 11, 3 plus 4, 7. So it is a 7. Now here 0. You have to come back to this 0. Now draw this. From 0 go to this. Then come to this. Go to this. And again come to this. 0 minus 0 plus 4 minus 0. It is 4. You can write it down. Writing it down is more, you can say, easy, but it will take time. Otherwise, you can draw like this. From the blank cell, you have to move. Now from 6. From 6, you have to move. You can either move this or this or this. But you have to come back. So from 6 to this 4, then 0, 0 and come back. 6 minus 4, 2, 0, 0. So it is 2. Are you understanding? This is the point. This is the only technique. You can write it down. No problem. Now 16. Let me write it down. Then from 16. This is C third. Now we are starting from C third. 2, we will go to A third. A third. Then from A third we will go to A fifth. A fifth. Then we will go to C fifth. And then again come to C third. You can see the circle. From here we are going to this, this and again this. So 16 minus 22 plus 0 minus 0. So this is equal to minus 6. This is minus 6. Now 14 is the blank cell. 14. From 14, you can directly go to this and this. 14 minus 11, 0, 0, it is 3. This you have to calculate. In the stepping stone method, you have to calculate the opportunity cost of all the blank cells. And the technique is by drawing the circuit, or you loop, or you can say closed circuit from the blank cell to the turning points of the occupied cells and coming back. Always turn at the 90 degree. Always turn at the 90 degree. So our purpose is to calculate the opportunity cost of all the negative cells. Here, there is another method that is known as MODI, Modified Distribution Method. Because our purpose is, what is our purpose? In order to proceed further, our purpose is to calculate the opportunity cost of all the blank cells where the allocation has not been made, and find out the cell which is having most negative opportunity cost, as this is most negative opportunity cost. There are only two cells, minus 4, minus 6, so this is most negative. Here we will draw the circuit, actually circuit. And then I will make you understand. But there is another method known as MODI, Modified Distribution Method, which tells us there is no need of drawing circuit each time, every time, again and again. You can follow only two mathematical equations.